Hello guys, today we are going to see what is networking room from TryHackMe. Coming to the first task, what is networking? Networks are simply things connected. For example, your friendship cycle. You are all connected because of similar interests, hobbies, skills and sorts. Networks can be found in all walks of life. A city's public transport system, infrastructure such as national power grid for electricity, meeting and greeting your neighbors, postal systems for sending letters and parcels. But more specifically, in computing, networking is the same idea, just dispersed to technological devices. Take your phone as an example. The reason that you have it is to access things. We will cover how these devices communicate with each other and the rules that follow. In computing, a network can be formed by anywhere from 2 devices to billions. These devices include everything from your laptop and phone to security cameras, traffic lights, and even farming. Networks are integrated into our everyday life, be it gathering data for the weather, delivering electricity to homes, or even determining who has the right way or at a road. Because networks are embedded in the modern day, networking is an essential concept to grasp in cybersecurity. The below diagram is an example. Alice, Bob, and Jim have formed their network. We'll come on to this a bit later. Networks come in all shapes and sizes, which is something that we also come on to discuss throughout this module. What is the key term for devices that are connected together? It is network. Okay, coming to the task 2. What is internet? Now that we have learnt what a network is and how one is defined in computing, just devices connected, let's explore the internet. The internet is one giant network that consists of many small networks within itself. Using our example from the previous task, let's now imagine that Alice made some new friends named Zane and Toby that she wants to introduce to Bob and Jim. The problem is that Alice is the only person who speaks the same language as Zane and Toby. So Alice will have to be the messenger. Because Alice can speak both languages, they can communicate to one another through Alice, forming a new network. The first iteration of the internet was within the ARPANET project in the late 1960s. This project was funded by United States Defense Department and was the first documented network in action. However, it wasn't until 1989 when the internet as we know it was invented by Tim Berners-Lee by the creation of World Wide Web (WWW). It wasn't until this point that the internet started to be as a repository for storing and sharing information just like it is today. Let's relate Alice's network of friends to computing devices. The internet looks like a much larger version of this sort of diagram. A network 1, a network 2 and network 3 connected through internet. As previously stated, the internet is made up of many small networks all joined together. These small networks are called private networks, where networks connecting these small networks are called public networks or the internet. So to recap, a network can be of two types, a public network and a private network. Devices will use set of labels to identify themselves on the network, which will come on to the next which will come onto in the next task below. Who invented World Wide Web? It is Tim Berners-Lee. Now coming to task 3, identifying devices on a network. To communicate and maintain order, devices must be both identifying and identifiable on a network. What use is it if you don't know whom you are talking to at the end of the day? Devices on a network are very similar to humans in fact that we have two ways of being identified, our name, our fingerprints. Now we can change our name through deed poll, but we can't however change our fingerprints. Every human has an individual set of fingerprints, which means that even if they change their name, there is still an identity behind it. Devices have the same thing. two means of identification, with one being permeable. These are an IP address and a media access control address, MAC address. Think of this as being similar to a serial number. IP addresses. Briefly, an IP address or Internet Protocol address can be used as a way of identifying a host on a network for a period of time, where that IP address can be associated with another device without the IP address changing. First, let's split up precisely what an IP address is in the diagram below. So the IP address will have 4 octets with the range from 0 to 255 each. An IP address is a set of numbers that are divided into 4 octets. The value of each octet will summarize to be the IP address of the device on the network. This number is calculated through a technique known as IP addressing and subnetting, but that is for another day. What's important to understand here is that IP address can change from device to device, but cannot be active simultaneously more than one within the same network. What's important to understand here is that IP addresses can change from device to device, but cannot be active simultaneously more than once within the same network. That means the IP addresses of the active hosts are unique. Okay, IP addresses follow a set of standards known as protocols. These protocols are the backbone of networking and force many devices to communicate in the same language, which is something that we will come on to another time. However, we should recall that devices can be both a private and a public network. Depending on where they are will determine what type of IP address they have, public or private. A public address is used to identify the device on the internet, whereas a private address is used to identify a device amongst other devices. Take the table and screenshot below as an example. Here we have two devices on a private network. These two devices will be able to use their private IP address to communicate with each other. However, any data sent to the internet from either of these devices will be identified by the same public IP address. Public IP addresses are given by your internet service provider at a monthly fee. As more and more devices become connected, it is becoming increasingly harder to get a public address that isn't already in use. For example, Cisco, an industry giant in the world of networking, estimated that there would be approximately 50 billion devices connected on the internet by the end of 2021. Enter IP address versions. So far, we have only discussed one version of the Internet Protocol addressing scheme, known as IPv4, which uses a numbering system of 2 power 32 IP addresses, that is 4.29 billion. So you can see why there is such a shortage. Now coming to IPv6, which is a new iteration of the Internet Protocol addressing scheme, will help to tackle this issue. Although it seems more daunting, it boasts a few benefits. That is, it supports up to 2 power 128 of IP addresses, that is 340 trillion plus, resolving the issues faced with IPv4, and it is also more efficient due to newer methodologies. The screenshot below compares both IPv4 and IPv6 address. We can see IPv6 address has more octets, that is 1, 2, 3, 4, 5, 7, 8 octets, but IPv4 has only 4 octets. MAC addresses. Devices on a network will all have a physical network interface, which is a microchip board found on the device's motherboard. This network interface is assigned a unique address at the factory it was built at, called MAC address. The MAC address is a 12-character hexadecimal number, which is a base 16 numbering system used in computing to represent numbers, and split into two twos separated by a colon. These colons are considered separators. For example, we can see the colons separated here. The first 6 characters represent the company that made the network interface, and the last 6 is a unique number. So the first 6 digits represent vendor, that is who built the network interface, and the last 6 characters represent the unique address for the system. However, an interesting thing with MAC addresses is that they can be faked or spoofed in a process known as spoofing. This spoofing occurs when a network device pretends to identify as another device using its MAC address. When this occurs, it can often break poorly implemented security designs that assume that devices talking on a network are trustworthy. Okay, take the following scenario. A firewall is configured to allow any communication going to and from the MAC address of the administrator. If a device were to pretend or spoof this MAC address, then the firewall would now think that it is receiving communication from the administrator, but where it actually isn't. Places such as cafe, coffee shops, and hotels often uh, use MAC address control when using their guest or public Wi-Fi. This configuration could offer better services, that is faster connection for a price if you are willing to pay the fee per device. The interactive lab attached to this task has been made to replicate this scenario. Okay. The interactive labs simulate a hotel Wi-Fi network where you have to pay for the service. You will note that the router is not allowing Bob's packet to the TryHackMe website and is placing them in the bin, but Alice's packets are going through fine because she has paid for Wi-Fi. Try changing Bob's MAC address to the same as Alice to see what's happened. Okay, let's deploy the site. Now we can see Alice network is passing. Let's see if Bob's passes. No, Bob's is not passing. Now, first let's answer the questions. What does IP mean? Internet protocol. What is each section of IP called? Octet. How many sections does an IPv4 have? 4. What does the term MAC stands for? Media Access Control. Okay. Deploy the interactive lab using view site button and spoof your MAC address to access the site. What is the flag? So now we have to spoof Alice address to the Bob. Let's type it there. 00:12:32:2f:33:39. Now, yes, now the network has been accepted because we have spoofed the Alice MAC address and we got the flag. Yes. Now let's go to the task 4. Ping. Ping is one of the most fundamental network tools available to us. Ping uses ICMP, Internet Control Message Protocol, packets to determine the performance of a connection between devices. For example, if the connection exists or is it reliable. The time taken for ICMP packets traveling between devices is measured by ping, such as in the screenshot below. We can see the time here, 2 microseconds. At one point it was 10 microseconds. Okay, this measuring is done using ICMP echoes packet and then ICMP's echoes reply from the target device. Pings can be performed against devices on a network, such as your home network or resources like websites. This tool can be easily used and comes installed on an operating system, such as Linux or Windows. The syntax to do a simple ping is ping space IP address or a website URL. Let's see this in action in the screenshot. We can see ping space an IP address. Here we are pinging a device that has a private address of 192.168.124. Ping informs us that we have sent 6 ICMP packets, all of which were received with an average time of 4.1 milliseconds. Now you are going to do the same thing to the to ping the address of 8888 on the deployable website in this task. Pinging the correct address will reveal a flag to answer the following questions. Okay, let's deploy this. Let's answer the remaining questions first. What protocol does ping use? ICMP. What is the syntax to ping 10101010? It is quite the same as given in the question. What flag do you get when you ping 8888? Okay, let's add IP address here. We can see a top text input bar. We are going to add our 8.8.8.8 IP address and send a ping request. We can see it is taking 7 to 9 milliseconds and we got the flag here. Cool. Now let's go to last task, which is task 5. We can complete this. It says to go to intro to LAN room next, that I am going to do in the next video. Thank you guys for watching this video. Please like and share this and watch my other walkthroughs to get knowledge on cybersecurity and its tools. Thank you.